We're going to talk about types of testing that are not particularly related to TDD. We're going to cover unit testing, some very important concepts, organizing and naming your solution, and then we'll get into MVC and how it was a big leap for Microsoft, and then we'll cover some specific testing scenarios around routing, controllers, and then if we have time, we'll talk about automated unit test or automated UI testing with Waitin. So, pop quiz. I like to start out the TDD talks with a quick 3-question pop quiz. No cheating. I can't see any of you, so we're all on the honor system. First question is, do you ever have to deal with spaghetti code? So you know the code where everything is intertwined and tightly coupled, and it's very difficult to maintain. So yes or no. Second question, have you ever inherited legacy code? Every company has that one legacy application that gets passed around from one new guy to the next new guy, or if you're lucky to have interns, that's the first application that they get to maintain. And lastly, are you ever scared to change code? If you ever get a change request and it's going to take, 5 to 10 minutes to change the piece of code that the request is referring to, but then you look around and you see that it's touched by 10,000 other places in the code, and it's going to take you 6 weeks to test it. That's always something fun to explain to the business. So if you answered no to all these questions, then consider yourself the luckiest developer in the world. But more than likely you did answer yes, and if you did answer yes to any of these questions, then you really need a way to alleviate the pain and hassle that comes with unmanageable, overly complex, poorly architected code. More importantly, you need a methodology or set of best practices that encourages writing better, cleaner, and more concise code. And that really is test-driven development, along with the techniques required to implement TDD successfully. But before we talk about TDD, let's quickly cover what is not TDD. So these types of testing are all very important, and implementing TDD does not reduce or remove the need for these types of testing. But what it does is it significantly reduces the time spent in these testing cycles. And it does that by reducing the number of bugs that get found in these testing cycles, as well as reducing the time needed to resolve those bugs, because your code is architected to adhere to TDD standards, so it's cleaner code. We'll just run through the list here. We have integration testing, so testing interconnected pieces of your application. Regression testing, which is testing pieces of code. After you make a change to one piece of code, you test your entire system to make sure you didn't break something else down the line. UAT testing, so once you're to a point where you can pass off your code to your business users, they go in their little room and do their testing and come back with their results. Performance testing makes sure that you hit all your agreements that you agreed upon as far as throughput and number of users. Load testing is testing to make sure how your app responds under load, not the normal load that you would adhere to, but more of a larger load. And then lastly, stress testing. How does your app respond when it fails? Are you displaying error messages with personal information and that kind of stuff? Again, these are all very important types of testing, and doing TDD does not in any way get you out of doing this type of testing, but what it does is it makes that type of testing easier and a smaller piece of the development lifecycle. So, test-driven development. Test-driven development is a software development process that relies on the repetition of a very short development cycle, and that short development cycle basically consists of 3 pieces. The first one is you write a failing automated unit test that tests new functionality or changes to existing functionality. Then you write just enough code to satisfy the unit test. That's important. One of the most important pieces to keep in mind is you write just enough code to satisfy the unit test. That alleviates that thought in the back of your head that always is, well, I'm going to add this functionality now because my users are going to ask for it next month. And eventually they may not ask for that, and then you have this code to maintain and to carry along into production. And lastly, you refactor the code to acceptable standards if applicable. So if you wrote just enough code and it may not adhere to your standards, then you do some refactoring. It's often referred to test-first development. So again, it's the process of writing your tests before you write code. And Kent Beck is credited with having developed or rediscovered the technique. And if you're definitely looking for a starting point for getting into TDD, look at Kent Beck's book. It's kind of the Bible on the subject. So unit testing. Unit testing is the key to TDD. Unit testing is the act of testing a piece of code, usually a method. It tests a very small piece of functionality by invoking it and verifying the assumptions. And we'll cover a little bit more on this slide about what makes a good unit test. So, what are the characteristics of a good unit test? The first one is it should be automated and repeatable. So I should have it behind some kind of automated unit testing framework, MS Test, whatever NUnit, whatever testing framework you're using. And it should be repeatable. So I should be able to run the same test over and over and over again and get exactly the same result. It should be easy to implement. So if it takes me a long time to write a test, chances are I'm dealing with overly complex code and my code should be refactored. So I should be able to quickly write a good unit test. They should be on demand at the push of a button. Again, the automated unit testing framework is the key here. So whenever I change a piece of code, I should be able to click one button and run my entire unit test suite. They should be fast. We're all developers. We want to write code. We don't want to sit and wait for our tests to run. So if you have a large unit test suite that takes a long time to run, your developers aren't going to run it. But more than that, if you have a strictly unit test suite that takes a long time to run, chances are you're not doing strictly unit tests. You're probably hitting one of a outside resource, which is what our last bullet point is. Can everybody make sure they have their mics on mute, please? Thank you. Our last point is isolated. These should be isolated unit tests. They should be testing a small piece of a class. They should not have external dependencies such as the file system, web services, databases, that kind of stuff. So again, they should be isolated. So compilation, as you can see the little walrus down there in the corner, compiled is not a unit test. So that's not part of the unit test process. We should all compile and make sure our code compiles, but that's really where it starts, right? And then the last thing I want to cover on this slide is bad unit tests. In my opinion, bad unit tests are really worse than no unit tests at all. They provide a false sense of security and they provide false system documentation. When you have a good unit test suite, a developer should be able to come on board and look at the unit test and understand the application and what it does. And if there are tests out there that are false positives, then that's misleading and going to provide incorrect documentation to your developers. All right, next is concepts and stuff. These are just basic concepts and best practices that you need to have always in your head when you're doing test-driven development. The first one is the single responsibility principle. So that's a principle that states a class should have one and only one reason to change. So if I have a customer class and I have a product class, if my product class changes, my customer class shouldn't change. My customer class should only ever change if something in the customer entity changes. There's some red flags to watch out for in your code that may be signs that you are violating the single responsibility principle. The first one is a method name with the word and in it. So if you're doing X and Y in a method, chances are that should be refactored into multiple methods to adhere to the single responsibility principle. Another red flag is methods that are greater than 75 words long, or 75 lines long, excuse me. If you have a method that starts growing in size, then chances are it needs to be refactored. Excuse me. And the last one is methods that have regions in them. If you have enough code in your method that you need to start collapsing it into regions, chances are you're violating the single responsibility principle and it should be refactored. The second principle, or the second concept, is program to interfaces, not implementations. So when you create classes that will be dependencies of other classes, create an interface on top of that to provide an abstraction. And when declaring dependencies inside a class, declare them using the interface. So if my class needs a logger, I'm going to declare my variable as iLogger and implement the concrete, and set that equal to the concrete instance. That way I'm always using that interface that I have to provide the solid contract between the actual implementation and the abstraction. And next is probably one of the most important principles for TDD. It's the dependency inversion principle. It states that high-level modules should not depend upon low-level modules. Both should depend upon abstractions. So the classic real-world example of that, you've probably seen this picture out on the internet, is soldering the wires from a lamp directly to a wall plug. You could do that and it would work. It would be painful trying to do, obviously turn off the power, but ideally we put an abstraction in between, which would be the plug. And this reduces the complexity of obviously plugging in a lamp or getting power to a lamp, but it also increases the portability of the lamp. Behind the scenes, the power generator down at the power station could change, and that's not affecting my lamp. It's providing an abstraction. All right. And next are two concepts that you need to keep in mind when coding your tests, when actually implementing tests. The first one is red-green refactor. If you're familiar with unit testing or TDD at all, red-green refactor is kind of the little song that you should be humming while you're coding. So the first step is red, right? We write a failing unit test, and most test runners have failing tests are denoted by a red icon of some sort. The second is green. So green tests are passing. So we start with writing some failing or a test that obviously fails because our code hasn't been modified yet. Then we modify our code to get our test to green, and then finally we refactor. And the last kind of concept is arrange, act, assert. And this is really important to keep in mind when you're writing your tests. I've ran into cases where people when they write their tests, they don't adhere to the same structure as they do in their actual production code. And it's really important to think of your test as live code. So this is a way of arranging your tests. So every time you look at a test, they're always in the same structure. The arrange refers to the first part of the test, which is for arranging. It means setting up any test dummies, whether that is instantiating fakes or setting expectations on mocks, and also setting parameter values and instantiating the class under test. The act, which is the actual act of performing what method you're testing, should always just be a single line of code that calls the method under test. And finally, the assert is the last section where you verify your assumptions. And this includes verifying any mocks if you're using mocks, as well as asserting against the object return from calling the method under test. All right. So let's get into setting up our foundation for doing test-driven development. We all start projects in the same way. We all go out and do file new solution, right? Or file new project. And that's really where test-driven development needs to start, as far as how you lay out your tests. The first kind of rule of thumb that I go by is that tests should be isolated from actual code. So as you can see here, I have a solution level folder called tests, and that's where all my tests are going to reside. And that allows me to have a cleaner solution for my actual production code, which is under the red box there. So that physically isolates my test code from my production code. And that just makes complex applications where you have a lot of items in the Solution Explorer, it makes it easier to traverse. The next kind of concept is that tests should be isolated from other types of tests to allow easily running a group of tests. So here I have integration and unit tests. Both reside in their own solution level folders. And that way, if you're using ReSharper or CodeRush or some other productivity tool, it more than likely will allow you to right-click on a folder and choose Run All Tests. So with ReSharper, I can right-click on the integration test folder and click Run All Tests. That goes back to the automated, repeatable, run-on-demand kind of key concepts that we touched a couple of slides ago, that I'm able to right-click and run all my unit tests in one fell swoop rather than having to run around and click one at a time to run them. And lastly, organizing your code so you can easily find out when you're in a method, an actual method that does something, that you can easily figure out where the test is. So here I have the red boxes around my service project, and I have my namespace for my service project .test.unit. That way, if I'm in my service project and I need to figure out where the unit tests are, I always know that they're in that namespace. And the last concept I want to cover before getting on to MVC-specific scenarios is naming your tests. How you name your tests is very important. You want to make sure that you're very descriptive, and long names here are actually encouraged. I know we don't, remember, you're not going to ever be calling these from actual code. You're just going to be running them from the test runner, so it doesn't matter if they're really long. You should be able to read a test name and know exactly what it does, and more importantly, why it would fail. So as you can see here, I kind of have a template. So method under test, underscore expected result, underscore condition. So an example would be get customers should return list of customers. And another example with condition is calculate rate should return 25 when interest is 50. Again, these are just contrived examples. But if you look at, if this test failed, if your unit test runner ran through its process and you had a red dot next to this one, the first one you would obviously know, well, I'm asserting against a list of customers is supposed to be returned, so I know exactly why that's not failing. And the same for the second test here. So I know it's not returning 25. So I should easily be able to read my tests and figure out what is wrong and have an idea before I pull up my tests. All right. Sorry about that. Just wanted to check Jabber to make sure someone wasn't yelling, hey, we can't hear you anymore. All right, so let's get into MVC specific stuff here. So if you're not familiar with MVC, MVC is a design pattern that stands for Model View Controller. What it strives to do is separate the concerns of an application's presentation layer by assigning specific roles to 3 different components. So the first is the controller. The controller is responsible for handling all user input. Once input has been received, the controller will perform any operations or actions it needs. These should be pretty minimal. It should be whether you call a service and the service handles stuff and sends it back up to the controller, or whether you're just returning and redirecting to another view. The model and the controller communicates with the model. The model represents the core concept or logic of the application. So if you're dealing with customers and products, a model would be a customer or a product. And once a controller receives some model data and performs any work with the model, it constructs a presentation model that describes the model in terms that the view can understand. And finally is the view, which is a visual representation of the model. It presents the model data to your user in a way that is meaningful. So in a web application, this would typically be an HTML page. All right. So ASP.NET MVC was created with a clear focus on best practices in both architecture and coding. And to be completely honest with you, this is my personal opinion, but this is truly a new approach from Microsoft. In the past, they've always set us up. I've felt that they've always set us up for failure, and it was our job to know better and keep ourselves out of trouble. For instance, ASP.NET MVC, there's a clear separation of layers. So we talked about that in the previous slide with the model and the view and the controller. There's no designer, right? If you're a web forms guy or a Windows Forms guy or Silverlight or WPF, you have a designer. You're dragging and dropping things, and you're able to do things like drag a database table onto your designer and hook it up directly to your controls. These are not best practices. And these are things you cannot do in MVC. Well, you probably could, but you'd have to do a lot of work to make that happen, where in the past, Microsoft made it very easy for us to get ourselves into trouble. So there's no server controls. We kind of covered that. And they're actually encouraging testing. That's something that's different from Microsoft. You wouldn't have seen that with web forms because web forms was inherently not testable. If you ever tried to test anything in web forms, you get about a layer deep before you find something that's sealed. And if you're trying to do true unit testing, dealing with sealed classes, it doesn't work. So if you create a new project in MVC, you do file, new MVC project, you see the create a unit test project that you can click on and include that with your MVC project. So that's a huge step for Microsoft. That's not something, like I said, that they would push with web forms. Granted, that button should be checked and you should have to uncheck it, but hey, one step at a time, right? And also MVC has a lot of DI points, so dependency injection points. You can inject controllers, views, action filters, model binders, view providers, all kinds of stuff. So they set you up to be able to input, whether you're inputting your own custom, injecting your own custom controllers or views or whatever, or third party, or if you're doing TDD for injecting mocks and stubs and fakes. So it's just a little approach on Microsoft as far as how MVC is different and is really geared toward testing. So if you've coming from a web forms environment and you've had a negative impact or a negative experience trying to do test-driven development, I would highly suggest coming in with a clear mind if you're coming into MVC as a new developer. All right, so that's my little speech that may or may not get me in trouble. So before we continue, I want to talk a little bit about MVC Contrib. So MVC Contrib is a project designed to add additional functionality and ease of use to MVC. It's created and maintained by members of the air quote Austin Mafia, many of whom are involved with aspConf. So Eric Hexter, Jeffrey Palermo, Jimmy Bogard, Brandon Santrum, a lot of brilliant web guys. There's a bunch of functionality in there that has been rolled into ASP.NET MVC in recent releases. But the piece I want to specifically talk about here is the MVC Contrib.test helper. There's a lot of functionality in there that we're going to cover that's going to allow us to easily test our controllers and our routes. And there's also some pieces in there for working with Waitin and automated UI testing, which we'll also talk about. So again, you can get that on Codeplex project. You can get it off of NuGet. Check it out, mvccontrib.codeplex.com. All right, so just like our HTTP requests that come into our website, we're going to start out with the routing engine. So when an HTTP request comes into our ASP.NET MVC site, it's handled by the routing engine, which maps the request to a controller and action based on the URL segments. So if I have a WAC customer, WAC index, WAC 1, that's going to map to the customer controller, the index action, and with a parameter of 1. So routing is basically what which allows us to have those clean, readable URLs. And they can get really complicated. If you're dealing with nested child relationships, and your URLs could get pretty crazy, and it's hard to debug. There are some, I know Phil Hack has a route debugger out there, but there are some route debuggers. But luckily, we can test this ahead of time, so we're not dealing with this in production, and we're not dealing with it while other developers are adding routes in. Another thing about routes is it's very important to remember that the order matters. It's always the first route it finds in the stack, it's going to jump out. So if you put your more specific route near the bottom, and another general route is found before that, you're kind of out of luck, and you may not realize that because other developers could be in there and not have the best understanding of how the routes work, and then things could get crazy. So it sounds like a perfect spot for doing some testing. So let's jump into a demo. We're going to demo abstracting our routes so we can access them from both our production code and from our test code, and how we can actually perform some testing on our routes. So here I'm in Visual Studio 2012. I have a new MVC4 project. So there might be a couple of differences here. If you guys aren't familiar with working with MVC4, I'll cover those real quick. First of all, you'll notice our out of the box that this is all that's in our global.asx, which is a little bit different from what we're used to. We are used to seeing our bundles in here and our routes registered. Well, now we have some config classes. So in this case, we want to look at our register routes config, or our route config. And in here is where you'll see the code that you're normally used to seeing in the global.asx. So Microsoft added a little bit of abstraction layer on top of that. So in here we're registering our routes. We have our classic ignore route because what's nice about MVC is it's still using the ASP.NET Core. So we still have access to things such as trace.axd. And we have our web API route, which is now included by default. But the one we're really concerned about here is our default route. So if you're not familiar with routes, how these work, Here's our segments that we talked about in the last slide. So we have a controller parameter, an action parameter, and ID parameter. So those are the three segments it's going to look for. So after the first whack, it's going to look for controller, the second whack action, third whack the parameter. So, and then I set some defaults. So in my case, I want my default to be my customer controller, my action to be index, and my ID to be 1. So we have our routes here, and I could easily copy these routes, and I could pull up a class I already have created called a route tester, and I could paste these in here, use ReSharper to do its magic, and then I have the same routes in my test class, my route tester that my production code is using. First, that should be screaming right as soon as I did copy paste inheritance. Copy paste, you shouldn't have seen right away, it's not dry, right? I repeated myself. Not only that, if I truly want these tests to live on and that I want to test all my routes, I'm going to have to make sure that when a route gets added to route config, that it also gets added to my route tester. Not ideal. So what I want to do with that is I want to create an abstraction on top of this that's going to allow me to access my routes in both places. So what I did is I created a route provider class, just a simple static class with one method in it called configure routes, and I copied in my routes from my route config and put them in here, and that's going to give me the abstraction that allows me to use the same routes when I'm testing as I do in my actual production code. So in order to use that, I can go over to my route config, and instead of doing this here, I can just do route provider.configure routes, and pass in the route object, and then I can do the same thing in my test to make sure that I have route provider configure routes. All right, so now, well, I should probably change some code so we're actually using this. Oh, looks like I did that already. So now we're using the same abstraction in front of getting our routes. So I'm able to use, in my route tester, I'm able to call route provider.configure routes, which configures my local route collection to have the exact same routes as my actual production or live route provider will have. All right, so now that we have that in place, we can actually start writing some tests. So some of the tests just that I might want to write for my routes is, the first one is to make sure, because I overrode the default parameters, I want to make sure that my default route, so if I go in with /whack, so just the localhost port whack, that it always maps to my customer and index method. So I wrote a test here. Again, we talked about naming. This is how I name my tests. I should be able to look at it and know exactly why it fails. So in this case, request going to whack should map to customer index. So in the range of my test, I have a URL, so it's just whack. And then I'm taking advantage of some of these extension methods that are built into MVC contrib test helper to take the URL and say that it should map to, in this case, custom controller, and the action should be index, and then again I have my default parameter, which is 1. So this is a pretty straightforward test, and this is going to allow me to test that if my routes change, if someone changes my default route, that I will know what happened. So I'm going to run this test. Unfortunately, I usually use the ReSharper test runner, but I upgraded to ReSharper 7 beta last night, and it broke the test runner. So I'm going to use the MS test runner. The test runner in Visual Studio 2012 is much nicer than in the past. So as you can see, we ran that and our test passed. So, and we can verify that it failed. You always want to do that, right? Just to make sure it was not a false positive. So I can do that and run this, and you'll see that it failed, and it should say that it expected 1 but was 0. All right, so that's one test I might want to write for my routes. Let me fix that test before it gets me into trouble later. And I lost my cursor. There we go. So what's another test I might want to write here? Let's see if we make sure that our ignore routes, it's another functionality that's built into the MVC contrib. If you have multiple ignore routes on there that you can test, or any ignore routes. So here I want to make sure that a request going to trace.axd is ignored. And what ignore means is it's not trying to be mapped to a controller and an action. Because if you send in trace.axd and it gets mapped to an action, a controller and an action, obviously it's going to blow up. And so the name of my test is request to whack trace axd should be ignored. So luckily, if you think about how you would write that, it would be pretty difficult to figure out how it was ignored. But luckily, MVC contrib has done that for us. So I have this test. Again, my URL is just whack trace.axd, and I am able to use the string extension method for should be ignored, and that'll run through and process it. And I can run this, and I should have 2 greens. There we go. All right. So other things that you might want to test in your routes is make sure that I would test the count, right? Because you want to make sure that when a route gets added, that it gets added in the right place. In order to do that, you need to let your developers know, if they're not familiar with that you're writing tests for all the routes, that when a route gets added to a collection, if that size increases, then a test should fail, so the developer knows they have to go in and fix that test, and hopefully realize that they have to write another test for their route. All right, so let's go back to the slides. There we go. All right, so let's move into the controller. Controllers should be thin and light. To be completely honest, they should be glorified traffic cops. Basically that direct input from the view, either down to the service and back to the view, or possibly in a different direction. So if it's a redirect, or it could even be just a turnaround. Hey, you're passing me an invalid model. Get back up there and tell the user that the model is invalid and it needs to be updated before we can continue on. Loosely coupled, we talked about this. If you have dependencies, they should be injected. You can do that in whatever way you feel is good. Unfortunately, with controllers, you don't have the ability to use constructor injection or getter or setter injection, excuse me, because all that is handled by ASP.NET MVC, the engine itself, instantiating the controllers. So you don't have the ability to do that. So you need another way to do that. The things to test inside of a controller, you want to make sure that the correct action's being taken. So if you're calling a method on your controller, you want to make sure that the correct action is being invoked. You could test that it redirects to the correct view. You could test that it returns the correct view, and also that it returns the correct model or type of model or the model that is correctly populated. So again, your controller shouldn't have business logic in it. I really can't stress that enough. It's not a 3-tier architecture in the MVC itself. MVC is a UI pattern. You still need to have a correct N-tier architecture behind it. That's really something to keep in mind. And TDD, obviously TDD is not meant specifically for model view controller. TDD should exist throughout your application. You should be programming the interfaces throughout your application. This is just MVC specific in this instance. So let's do some more demoing. In this demo, we will isolate and test our controller. All right. So I'm going to pull up my current controller here. I have a customer controller. Again, if everybody could mute their microphone, please, that would be great. So in my controller here, every controller in my application here is going to have a logging service and then a service that represents whatever entity we're dealing with. So in this instance, we're dealing with a customer, so I have a customer service. All right. So right now I'm using a structure map and I have a dependency resolver that I wrote that I can use to resolve my dependencies. But I'd have to do this. Sorry, laughing at the comment on Jabber. That's pretty good. Back on track. The customer controller has a logger and a customer service, and I'm using a dependency resolver to resolve these dependencies. Now, I could do this in every class. It's kind of what I have to do in other layers of the application, but wouldn't it be great since MVC, the engine itself, is already taking advantage of the convention over configuration to generate my controllers, that I could somehow plug in my dependency container and have it automatically resolve my dependencies. And I actually can. I'm not going to leave you hanging and just say, wouldn't it be great? Because we actually can. And we can do that by creating a custom controller factory. So what I have here is I have a controller factory, and it's basically just a class that implements a default controller factory. I have some constants up here to deal with the actual get controller instance method, which actually resolves the controller. Unfortunately, I cannot force mute everyone. Sorry. I wish I could. But please, if you are not muted, please make sure you are. So the meat of this, or what's important at this point, is right here, that I have a public instance of a structure map container. So you could do this with your DI IOC framework of choice, Ninject, whatever you're using, Unity. It works the same way. But I have an instance in this for structure map. The actual IOC container is called iContainer. And here I have in my controller factory constructor, I'm creating a local instance of container, or I'm setting my local instance of container equal to the structure map container. So that's really all I have to do. And then there's one more step. I have to go over and tell ASP.NET MVC to use that controller factory. And I do that by going in here, make sure I do that after I wire up my dependencies. And I use the built-in controller builder, .current, .set controller factory, and then I can new up an instance of my controller factory. And just by doing that, I have told ASP.NET MVC not to use the default controller factory, which limits me as far as I must have parameterless constructors, and set it to my new controller factory. So I can go over to my customer controller now, and I can put some input parameters on my customer controller. And if I would have tried to do this before, obviously MVC would have blown up on me, because at the default controller factory you must have parameterless constructors. So I can, since I'm programming the interfaces, I can do logging service as a parameter, and also customer service as a parameter. And then all I need to do is set those equal to my private instances of those. And at this point you might be thinking, well, that's not going to work, right? Because you don't have access to pass those parameters in. And it really is pretty slick how this works. So just to prove that it does, I'm going to set a breakpoint here. I'm going to hit F5. Wait for... Oh, we got this over here. I'll drag this back over. So my app's spinning up. And you can see my breakpoint was hit, and I have concrete instances of my services. So I have my concrete instance of my logging service and my concrete instance of my customer service. And that was just by creating the custom controller factory that implements the default controller factory. And then by telling MVC to use the new instance and putting the parameters on the constructor parameters on. And it was able to use structure map to automatically resolve my dependencies. So now I have loosely coupled controller code. Again, if everyone could make sure that they're muted, please. Somebody is definitely not muted. All right, sorry about that, guys, but I guess we'll just keep going with that going on. All right, so now that we have the loosely coupled code, all right. Now that we have the loosely coupled code, let's actually get in there and test it. So I'm going to pull up my test here. So customer controller test. All right. If anybody knows that language and could instruct me how to speak, please mute your microphone. That would be great. So I'm in my test class, and I want to write a test that makes sure that my index method returns a view named index. Now I could write this, and I could do all the interrogation of the ASP.NET MVC view engine or ASP.NET MVC engine myself, and have to figure out where my requests are and deal with the HTTP context. But I would rather not do that myself, and I would rather take advantage of MVC contrib again. So MVC contrib has some built-in methods here. Looks like we have some stuff to resolve. If anybody has any questions about the toolings I'm using here, I'm a big resharper guy, so that's where I'm getting all my automatic reference resolution. So I created a test here. I'll get that a little bigger so you guys can see. It's named index should return view named indexed. So if I go back to my controller, let's clean this up so we're not jumping around so much. Look at my index method on my controller. Basically all it does is it does some logging, and then it excuse me, it returns a view with a customer that comes along as the model. So before we look at that test, I want to jump and take a look at fakes and stubs and mocks. You can see here I have a logging service fake and a customer service fake. So this method isn't concerned about what comes back or what happens on the call to the logging service or the customer service. What it's concerned about is that the right view is rendered. So I need something to put in the place for those two services, just to say, hey, don't bomb. We have an instance, and this fake instance is just going to do just enough to satisfy the code to allow it to continue. So I'm going to attempt to pull up here. Guess we'll go this route. Pull up the logging service fake, and all I have here is just some empty methods. These are all void, so they're just empty methods that allow it to continue. Probably not the best example. Our other one we can look at is our customer service fake, which in this instance just returns a new customer. Because if we go back to our controller, it calls the customer service.getById, and just to allow it to continue without blowing up, I'm saying, hey, return a new customer. So this is a fake. All it does is it satisfies the interface, and it returns or does just enough to allow the code to continue. Stubs are very similar, except they have a tendency to have a little bit of state in them. So if you have a list that you're adding to, there could be a basic list in there. Mocks are a whole different beast. With mocks, you actually need some tooling behind it, whether you're using RhinoMock or MockU or NMock or any of the plethora of mocking frameworks. And with those, you actually record and make sure that it does exactly what it does, or excuse me, what it's supposed to do. So back to our test here. We have our two fakes that we're injecting and passing into our controller. So I was able to create a controller that allows me to pass in parameters. So I'm able to pass in my fakes. I am using a specific mocking framework. I'm using RhinoMocks, and we'll get to that in a little bit. So the first thing I do in my arrange is create my controller. It's going to be my class under test. And then I create my result. So I'm calling my controller.index and passing in my index value of 1. Setting that equal to an action result, because we know that's what comes back from controller.index. And then I take advantage, again, of another extension method that's on top of action result that MVC contrib provides. And it is a method that allows me to check to make sure that the correct view is being rendered. So I'm saying, is this result? It should be a view for the index.cshtml. So again, I could do this and interrogate the response that comes back from the HTTP request and do all that nasty logic. But luckily, the great guys over that worked on MVC contrib have already done that for us. So now I have this test in place, and I have to run them all because I'm not from uh-oh. So we have a build error. Let's figure out what's going on. Oh, somebody put an extra tick in there. All right. So let's run that again. And you can see that that passed. So this is this test here. Index should return view named index. So just to prove that I'm not running some pre-compiled demo here, I can run this and say, hey, we're looking for index 2, and it fails, and it says expected view name with index 2, but the actual was index. So again, your controller should be very lightweight. So this is the extent of the testing you should be doing. You shouldn't be testing that, you know, the business logic you have coded in your controller is working, because you shouldn't have business logic in there. All right, so let's see what else we can test in here. Let's make sure that we get the right cursor. There we go. That we get the right model back. If we look at our customer controller, it not only redirects to the view index, or not redirects, but displays the view index, but it also returns the model that comes back from customer service.getById. So we want to make sure that we get all that back. And that everything is behaving accordingly. So let's put this test in here. So this test, index should return a view with model of type customer. Well, looks like my copy code is missing some things here. Again, the logic should be very similar. I'm instantiating my controller. If this was not for a demo, I would obviously take advantage of class initialize or test initialize. Since I have some duplicated logic here, take the controller out, put it up there. The instantiation, I have a private controller. Again, just because they're test doesn't mean you shouldn't be adhering to best practices, but because I'm doing an online demo, I'm don't have to follow those. Wink, wink. So again, creating our controller, and action result equals controller.index. And then we can do this nasty looking thing here, which we'll clean up in a bit. Basically what I'm doing here is I'm converting the result that comes back, my action result, to a view result, and then I'm getting the model of it, and then I'm doing a type of to make sure it's a customer. So common.domain.customer. At this point, I'd like to introduce you to another little NuGet package that I live by, and it's one of the first things that I install. I just want to see if I have it installed, and I don't. So we will bring up the package. Well, we'll bring up the package manager here. Other windows. If you're not familiar with NuGet, definitely check it out. NuGet.org. Package management for .NET. Package management console. And I'm going to. There is a GUI. If you right-click on the references folder and do manage NuGet packages, you get a GUI. Package install should. That's not what it's called. Package. Oh, thank you. I knew that. Install package should. There we go. See, we got some IntelliSense there. So now it's pulling down should from the NuGet servers and installing it. And again, if you're not familiar with NuGet and its magic, what it did is it went out and got the DLL and it put it in. Should have put it in here. Is that not the right project? Oh, wrong project. No, it's the right project. Huh. Oh. Yeah, you got to watch out for that. So I was in the wrong, I had the wrong project selected here. There we go. Now we have should in there. All right. And what should is going to allow us to do is it's going to allow us to write a lot cleaner assertions. So instead of doing assert.is of type, all this other stuff, I can pull out my I'm just going to copy it over here. So comment out this guy. So this allows me to have a more fluent, more BDD, if you will, assertions. So it's still a little ugly because of the casting I have to do here, but should has cleaned it up quite a bit. So instead of doing is instance of type and having to cast over here to type of common.domain.customer, I'm able to use the extension methods that come along with should and do model.shouldBeType common domain.customer. So that's a lot more English readable, more readable code that a developer can look at that's not familiar with all the casting and be able to figure that out. All right. So there's one more thing I want to test in my controller. I'm having cursor issues today. Third monitor is not picking up the cursor. There it is. All right. So I have another method in there. We'll pull up customer controller. So we have our index get, our index post, and we have a redirect to action here on our post. And we can test that as well to make sure that things are working the way they should. So I can paste this guy in here. So my index post method should redirect to step 2. So we go back to our controller. Make that a little smaller. So index, the HTTP post attribute on it should redirect to action step 2 of customer. So it should redirect down here. And again, we can take advantage of the MVC contrib assert action redirect that it asserts to the right action. And I don't think I ran my other test to prove that that one worked either. So we can run all those, make sure everything passes here. And you can see that all of our tests pass. So in that, I was able to write some tests to verify that my controller is doing what it's doing. Again, you shouldn't be concerned. You want to make sure the right model type is coming back, it's directing to the right view or redirecting when it's supposed to, or if you pass a model with invalid model state, that it's redirecting to the same view. That's the gist of what you should be testing. You shouldn't be testing business logic in your controller. Number one, And really the only reason is because business logic does not belong in your controller. All right. So now that we have controllers, all right, since we don't have a moderator, I'm looking for you guys on Jabber to yell when we're getting close to time. So let's pull up our slides again here. All right, so let's talk a little bit about waiting. Waiting, watting, you say potato, I say potato, right? It's automated UI testing. Oh, we have another 30 minutes. Sweet. Do we really? I think we have 15 and then 15 for questions. But so waiting, automated UI testing. In the past, automated UI testing was very expensive. It was something you would have to bring in a third-party package for. It was very intensive as far as writing all the scripts. It was something that typically was out of the general developer's hand. You'd have an enterprise architect team or a web testing team that would handle that. So it's if you look at the Watton site, its actual pronunciation, it's actually enunciated on there as waitin'. So it's not really slow, but that's for some reason that's what they named it. All right, so it's automation for your browser. So it allows you to write tests using C# with your favorite unit test runner to automate the browser. It supports IE, and if you're real lucky and real good, you can get it to work in Firefox. I have never gotten it to work in Firefox. It doesn't support Chrome. There are other alternatives such as Selenium. But it allows you to test basic UI functionality. So this isn't something you're going to use to fully automated UI test your entire suite, right? You're not going to test it for workflow and all that kind of stuff. It's for basic logic as far as navigation from page A to page B, display logic, if you're running a bunch of scripts as far as checkbox shows up this field and hides this field. It's great for that kind of stuff. You can test dialogues. One place I really like to use it is for making sure that validation messages are displayed and that fields have the correct validation in place. And the last bullet point is free, right? So free is always good, especially when you're trying to convince the pointy hair bosses that this is something you need to do. If you say it's going to, add another 10% to the development life cycle, and then on top of that you say, oh, and the tooling costs $5,000, they're a lot less likely to allow you to do it than it would be that if you tell them that the tooling is free, right? So again, this is only one tool that's available for doing automated UI testing. I suggest, but the concepts and the ideas are the same. From a developer perspective, doing automated UI testing, again, you need to keep in mind that this isn't a full suite of tests. You really want to deal with one page at a time and make sure that it navigates to where it's supposed to go, that the correct fields are displayed, that the correct validation is in place for the pages. It's not meant to be a full UI test. All right. So let's look at some demos for automated UI testing. That didn't work. Whoa, we're back at the beginning. All right. So you can get waiting from NuGet again, just like I showed you with should. You can pull up the package manager console and install package waiting. If you do that, if you use the NuGet package, there is something wrong with the current version of the NuGet package that when it comes down, I lost something here. There we go. then when it comes down, you need to go into the properties window of this guy, interop.shc.docvw, and Studio's kind of flaking out here. And I'm not going to try to do it because obviously Studio is not happy with me. You need to change the embed interop type to false. If you don't do that, it will not run. So make sure that you do that. So I'm going to pull up, I'm going to go into my UI tests. And I have a folder in here for views, customer, and I want to look at the index test. And inside of here, the basis of dealing with Watton is a browser object. So up here I have a new IE, so I'm going to be using IE, called it _browser, so IE is type watton.core IE, which derives from watton.core.browser, and also a URL. So this is the URL to my default page. So I want to write a test to make sure that, again, when I come in it with just whack, or I come to this URL, that the customer index page is displayed. So I'm going to write a test here. You might have noticed that little shortcut I did there. So I had created a unit or a ReSharper live template for unit tests. So I have two for TT. That'll do a standard test. And then I have another one for TW that does when what. If you want those, they're out on my blog, .netdevdude.com. All right. So what are we testing here? We are testing that customer index should be displayed as the default page. All right. So we have our browser, and the first thing we need to do, we have our URL set up. So inside of our act, we're going to do _browser equals new IE and pass in our URL. And that's basically all our act is. And then we need to interrogate our browser object to make sure that the right page is being set back. And we can do that using the page title, which is the actual HTML title, not like the title displayed on the screen. So I can use browser.should. Hopefully I have should installed here. We'll get to that. Browser.should. No, sorry. Browser.title, and it's not that browser. Browser.title.should equal customer index, because that's the actual name on there. Do I not have should installed here? No. Excuse me for 1 second while I test.ui. All right. All right, so browser.title.should equal customer index. So what I can do here, I'm going to set a breakpoint here so we can actually see what's going on. And I'm going to debug this test. So again, I'm not all that familiar with the MS Test Runner, but I'm being forced to use it. So I'm going to debug all tests, and hopefully Should see my browser pop up. I'm not sure if it's going to pop up in the correct window though. There, oh, popped up over here, unfortunately. So this just popped up, my instance of IE. You can see I hit my breakpoint there. And if I run this, F10, we should get a passing test. Yep. So it popped up, it stayed up, and it automated the browser to confirm that the right page was displayed. So because it stayed up, we want to browser.close because we don't want a bunch of those up. And because it has a dispose method, we're going to call it. And now if I run this, it'll kind of silently spin up the browser and I won't have to watch it spin up. And it passed again without me seeing it. So that's one thing I can do with waiting. What else can I do? Well, I want to make sure that when I run my page and I click my next step button, that it goes to page 2. So let's run this app so you guys can actually see what this does. So it's a real simple page. I have a create new customer link, and I have a next, which basically does nothing but go to a page called step 2. So what I want to do is make sure that when I click that button, that it actually goes to step 2. So I actually want to automate the button click. So I have a test for that. And I'm running, so it's not letting me. So here's my test for that. Basically does the same thing. I didn't need that in there, but declares the URL, spins up a new browser, and then this act actually does the button click. So we're saying browser.button, get the button with the ID of next, and click it. And then we need to validate that we're going to the right title. Or I'm sorry, the right page by interrogating the title, and again we close and dispose. Close and dispose. So if I run this and put a breakpoint in here again, we should be able to. So test, debug. See that. And actually see the button click. So is it going to let me put this over there? No. So I'm going to exit full screen so I can put this over here, put this over here. And now when we step through, you'll actually see the button click. The button should turn orange or yellow when we click on it. Yep. So there we just clicked our button, and you can see that our actual page turned, and we got the right browser title, and it closed our browser for us. All right. I'm going to skip a couple demos here, or a couple pieces, because I want to get in and test the. Looks like we're coming up on question time here. I want to test the. I'm going to explore here the create to make sure that my validation is in place. So I'm going to run my app so we can see the validation that we have in place. Run. So my create new customer page, first name is required, last name is required, and date of birth is required. So I want to test that when I try to submit, and I don't have one of these, or have the first name field filled in, that the actual first name is required button, or the first name required message is displayed, and it doesn't continue to process. So now I'm over in my, again, I'm running in my create test, so the test for my create.cshtml page. And again, I'm spinning up the browser. I have, we talked about long test names. Here we go. I'll probably win something for that. First name is required validation message should be displayed when clicking create without filling in first name field. Ha. All right. Again, you don't ever have to call those. It's okay for them to be long like that. So we spin up a new browser. We click the create button without filling in the first name field. And I want to make sure that the span, so I have a span and it's for the first name validation, that it is displayed and the inner HTML should equal first name is required. So I'm going to run all these tests and make sure that this passes. I should see a new test come up here. Thank you for telling me there's 15 minutes left. And there we go. And it ran that. You can see here's our big long first name is required test, and it ran that and it succeeded. So that was able to test to make sure that when I clicked the button and it wasn't filled in, that the validation message was displayed correctly. But I also want to write a test and make sure that the validation message is displayed correctly, or in this case not displayed at all, when I click submit after filling in the first name field. So this one is the same thing. First name is required, validation message should not be displayed when clicking create with first name field filled in. So this I'm actually automating entering data into a text field. So I have my browser, spin it up to my URL, I get the text field and I tell it to type text. So type text Joe, press the button, and then we should be able, then we try to get our span here, which represents our validation message, and we call the should not exist, or exist should be false. All right, and again I'm going to put a breakpoint in this guy so we can actually see it spin up and enter text into the field. That was the wrong button. I have to wait for that current test run to stop now before I can debug. All right, I think it's, no, we'll just cancel. So, test, debug, all tests. My browser spun up over here. It didn't stop in the right spot though. Where'd it go? All right. So put this over here, this over here, close this. You can see we stopped right before entering text in the text field, and if you watch the first name field here, what's going on? There we go. If I hit F10, you can see it turned yellow and Joe actually typed up here. And now the create button should turn yellow. You can see our validation message is not displayed for that. So we should be able to go in here and results.exists should be false. So our test should pass with flying colors. And just like that, we have all of our tests are green. So with that, we were able to write some automated UI testing, just like we would write standard tests using Waitin and its ability to automate the browser. Again, if you're going to use something like Waitin or Selenium, you need to get very familiar with the browser dev tools so you can go out and interrogate your DOM to figure out what elements are named what and where they are. There's pretty much all the functionality you need built into Watton to traverse your DOM, to figure out where things are, and write scenarios so you can verify that everything is working as it should be. All right, I got about 15 minutes left, and I'm going to start wrapping up. We had a question about slides and demos and code. Yes, slides and demos and code is all going to be available on my GitHub page. If you have not heard, all the videos for aspConf will also be made available eventually on Channel 9. That's a huge amount of effort, and we thank the aspConf guys for taking care of that, because I know there's some that I definitely want to go out and watch as well. So again, github.com/kburnell, testdrivingASP.NET I have a lot of other projects out there on GitHub if you want to take a look at those as well. So thank you for listening to my session, and thank you for supporting aspConf and coming out. I hope you guys enjoy the day. If you would like to reach me, my Twitter is @KEBurnell. My website is .NETDevDude.com, and my email is keith@.NETDevDude.com. So at this point, I will take questions. I see we have some questions in the queue here. All right. First one. Where would you recommend putting your view models, since the domain model is separated out into separate assembly? In addition, how would you handle areas since it's separated out? View models are definitely UI specific. So my view models would definitely be in the UI project. So what I typically do is, like you saw, I separate out my models into a separate project. I would replace the default models folder that comes along with MVC with a view models folder. I'm definitely a huge proponent of view models. There are always scenarios where you're displaying a subset or a superset of your data, which requires a view model, or you're tracking UI specific things. Oh. Not sure what happened there. Okay. All right. Thank you. Do I see a value in ATDD? To be completely honest with you, I'm not sure what that stands for. Let me pull up Jabber to see if anybody's going to tell me what that stands for. Oh, there we go. Acceptance. Why is my window so small? Acceptance test-driven development. To be honest with you, I'm not familiar with the concept. All right, the next question. I had an issue with circular web references when I tried to have a solution set up with models in one project, tests in another, and the MVC project in a third. Ever run into that issue? I have definitely ran into that issue. What I end up doing is creating typically my domain class. So my domain where I keep all my models is referenced by every class, and it's an extension of my commons class. I would show you guys code, but they took control away from me. So what I typically have is I have a .common and then a .common.domain. Once you get very complicated, refresh your browser. You definitely do run into situations where circular references can occur, and you just need to modify the code to get those references resolved. All right. If business logic doesn't belong in the controller, then where does it belong? That's a great question, and I'm glad that my preaching of the business logic not in the controller has gotten you thinking. Business logic belongs in a business in your business layer. So typically you would have your web layer, like I had, that would have your models, views, and controllers, and your controllers would call either via service or direct project linkage to a service layer or a business layer, and that's where your business logic should reside. Next question. If time, could we briefly cover hooking in the DI container again in the controller factory. I can't because they took code or they took drivability away from me. But if you check out, if you Google test-driven development, or I'm sorry, Google with Bing, test-driven development with ASP.NET MVC in MSDN, you can get the article that I published last month, and that has covers extensively how to hook up the DI container into the controller factory. So UI automated tests used to be very slow. Have you ever tried headless browsers? I have not. I've had that recommended to me a few times. It's definitely something that's on my list of things to look into. What is a good way to test controller actions that require authentication or perhaps even session state? MVC Contrib handles a lot of that. I kept the demos a little high level for this presentation, but I would definitely recommend looking into MVC Contrib for that. When do you decide to create a fake rather than a lightweight stub? I pretty much always create fakes. Again, they're just, if I really need to track what's going on, I'll use a mock. Or if I have a instance where I actually have hard-coded values that I know are not going to change to be returned, then I'll create a lightweight fake to return those a lightweight stub to return those values. Where would you recommend putting your view models? Since the domain models, I think I covered that one already. Again, view models would go in the web project. Code will be available for download. It's on github.com/kburnell. That's KBURNELL. You mentioned the test shortcuts are on your blog. What was the blog URL? My blog URL is .netdevdude.com. So .netdevdude.com. For devs who haven't done a lot of TDD, can you pick this up on a paid project, or does learning all these various tools take a lot of private experimentation and practice time? That's totally up to your customer, right? If your customer is willing to pay for a testable solution, I'm getting feedback now, then definitely yes, you should be able to pick it up to get paid to do it. But to really, unless you're very lucky to have a client that's going to do that for you, I suggest doing it on your own. How are testing against Entity Framework and nhibernate in the model? I have extensive experience with Entity Framework Code First and MVC that I've done, and because they're just POCO objects, there really is no issue with testing them. But as far as other types of the model first or database first Entity Framework, that'll get pretty hairy. So I would recommend trying to abstract those away. All right, I think we got a couple more minutes here. Watton seemed very slow. How well does it work in larger projects? We try to keep our tests under 3 minutes. Again, these aren't unit tests. So they are, I mean, you're hitting the browser, you're hitting the HTTP or IAS servers. So these are integration tests. So I wouldn't lump these into the tests that need to run under 3 minutes. Because if you have a complete set of integration tests, those are not going to run under 3 minutes if you're putting stuff in the database. So it would be nice to be able to run these a lot quicker, but again, they aren't unit tests, they are integration tests. Mountain seemed very slow. I think that covered everything. All right, the questions have been cleared out. So thanks everybody for coming out. Enjoy the rest of ASPConf.